I'm in the guitar room today because nothing says performance like rock and roll. And today we're going to talk to a performance expert. So play the music. Hi guys, and welcome to the show. I have Yong Rhee with us today, and he is a senior PFE. Yong, say hi.
Hey guys, how are you guys doing?
So today we're going to talk about performance, and that's an awesome topic. I'm a great networking guy. I love reading network traces. I can read a perfmon fairly well, but we've got some awesome new tools that kind of take us beyond the average perfmon, right?
Yes, absolutely. It takes us a little bit deeper into under the hood of Windows. So it will give us a lot more in-depth information, which, a lot of times when you're trying to get to the root cause of issues, you want to get down to the user mode, kernel mode, and look at the stacks.
Yeah, so we used to have to do that with debuggers, right? We used to have to either do a live debug,
right,
or we'd have to force somebody to do a memory dump and then get the dump file and then try and figure out what was going on. It's much easier these days, I hear.
Yeah, so in the past, the primary tool that we had was to go ahead and take a user mode dump, right? Anytime you do that, the process pauses, right? And because of that, the process that you're troubleshooting might become unresponsive. If it's a SQL server that is 60 gigabytes, it might take a bit of time for SQL to become responsive again. With this tool set, we are getting that out of the way and capturing data while the issue is occurring on live Windows servers.
That's awesome. So tell me a little bit about the new tools.
Yeah, so it's the Windows Performance Toolkit, and it's a free download from the internet. Just look for the Windows 10 SDK or the Windows 10 ADK and go through the installation process. One of the options in there is going to be the Windows Performance Toolkit. The toolkit comprises of three major processes in there. Two of them is to collect data sets. One of them is called the Windows Performance Recorder UI, so that's the graphical version of it. And the other one is if you're looking at creating a batch file or running a PowerShell command, it's a console-based, so you could run it from a command prompt. And the third tool set is to analyze the data set once you take it off from the server, so that we're able to take a look in depth while not impacting the machine that is having the issue.
And that last one's the Windows Performance Analyzer?
Yes, that is the Windows Performance Analyzer. And a lot of times you're not going to have that on the server itself, right? You're going to take the data off of the machine and you're going to be looking at from a tools machine, so that you could access the internet for the symbols if you needed to, or if you were in a closed circuit or a secure network, you could go ahead and pre-download the symbols and just point it to those symbols that you have downloaded and analyze it that way.
Wow. Okay, so I'm a little bit stunned, and here's why. I have downloaded the toolkit and I've run it and kind of collected some data, not really knowing what I was looking for, but I'm hearing you say that you can actually pull symbols into the tool.
Yeah, so that's one of the advanced features, right, that great tools like sysinternals, Process Monitor, Process Explorer, and others such as the Windows Debugger have, which will, elevate your troubleshooting from a level 300 to a level 400, right, because it will show you all the modules and all the functions that are being run in the modules, so that if you needed to get either the vendor or Microsoft support to investigate further, they're able to go down to that level.
Yeah, that's cool. So can you show us a little bit?
Absolutely. So let me go ahead and start sharing my screen now. After installing the Windows Performance Toolkit, you'll see that on 64-bit systems, it will install into the x86 Windows Kits 10 folder. Inside of it, you'll see the Windows Performance Toolkit. If you double-click on it, you're going to go all the way down, and you'll see the Windows Performance Recorder UI, and we're going to right-click and run as administrator. Once you do that, this will come up, and you can see here that it has a good amount of options. And the first option that you want to go through is going ahead and selecting the issue that you're troubleshooting. So if you're troubleshooting a high CPU problem, you want to go ahead and check that box. And if you have a disk problem, you want to go ahead and check this one. If you have file access issues, registry, networking, heap, which is private bytes, page pool, non-page pool, virtual bytes, power issues, graphics rendering problems, handle leaks, RAM issues, and the one that a lot of servers run into is with the filter drivers, and that could be the antivirus filter driver, or that could be the quota management software, or it could be the firewall driver that is on the system.
Yeah, that's pretty cool. That's a lot of stuff. So what if the complaint is, hey, my system's running slow? Is there like a general set that we can use?
Absolutely. If your system is running slow, the first thing that you probably want to go ahead and do is just do a first level triage and see what the problem might be. If the symptom is things are running slow randomly, where a service is responsive for 50 seconds and it seems to hang for 10 seconds, or if a process, an application is unresponsive for 5 to 10 seconds or 30 seconds, we have this option for checking the box for CPU usage. Not does only it collects CPU information, but it also collects context switches, which we're able to use for weight analysis, which most folks call it hang analysis.
Okay, that's pretty cool.
Yeah. And the other things that we're able to do with the tool set is we're able to get boot, shutdown, restart information on servers. So sometimes, depending on the group policies that are in place, if you're booting from SAN, as an example, it might be slow, and if you want to find out why that server is taking a long time to boot, this is one of the options that you could go ahead and select and take one sample of that slow boot. Obviously, when you're troubleshooting SANs, you want to go ahead and add not only CPU, disk, file, but also those SANs are probably going to be connected via either an HBA or iSCSI. And for those, we could add custom profiles and point it to those custom profiles as such as store port or for iSCSI specific data collection stuff. So
yeah, that's cool. Can we so let's collect some data and take a look at the results.
Okay, absolutely. So let me go ahead and show you guys. We have a test tool by Aaron Margosas called Vernon Test. And this tool set is great at going ahead and showing us different symptoms that you could run into. So what I'm going to go ahead and do is I'm just going to go ahead and collect a regular high CPU utilization issue and showcase how the data collection would go about.
Oh, okay. So I get it. So hang on, Young. So sure. the other tool, the VirchMem tool or test tool, that's going to generate high CPU for us? Is that what we're saying?
Yes.
That's awesome. Good deal.
All right. So let's go ahead and bring up Task Manager. And you can see we already have some CPU utilization on the system. We're just going to add a little bit more by adding a thread to go ahead and utilize CPU. I'm going to go ahead and click on Start. I'm going to click on Run CPU Hog, and we're collecting data right now. You can see that the CPU hog process is using up some additional CPU on the box, and you don't have to collect for a long time. So 20 seconds should be enough for a data collection on a server. So I could put in some description: high CPU by Vernon Test. And by default, it goes ahead and saves it to your profiles, document, WPR files. So we're going to click on save. And the reason that I only collected data for 20 seconds was because on modern processors, we're going to be capturing roughly 20,000 samples per second. So that's a lot of samples, even on a 20-second interval. We should have enough data sets to be able to get down to the problem. So once we're done here, we could go ahead and close the application. And you can see that the data says, hey, it may contain some personally identifiable information on the trace. So you want to be careful, just like with a memory dump or kernel dump. We're going to go ahead and click on Open in WPA. So you could either click on here or manually copy the path and open that in Windows Performance Analyzer. We're going to go ahead and click on Open in WPA. And we're minimizing the Windows Performance Recorder. I'm going to go ahead and maximize this. Now, one of the tricks is if you're analyzing the Windows Performance data set, one of the things that you may want to have is a widescreen monitor so that you have enough areas for the columns to show up. Now, if we see this, by default, it will come up like this. And you can see that there are these different graphs. These are groups. There are system activity groups, computation groups, storage, memory, and power. Each of these groups have different graphs inside of them. And if I'm troubleshooting a high CPU utilization, just like I was doing just now on this system, I could just sorry, go ahead.
No, that. You keep going. I was just saying that's cool.
Okay.
That's neat. Yeah.
Okay. Yeah, so if I just double click on here, you'll see that we'll have the information of the processes in question. And the one that I know Skype is using up that much of CPU because I'm using it for recording, but the process that I'm interested in is this Vernon Test. For the sake of some additional space, I'm going to go ahead and unpin it up here. And I could go ahead and expand here, and I'll be able to see root and all the DLLs and EXEs that were part of that process when it was using up the CPU. Now, what you'll notice is that percent weight is the percent of CPU utilized by the process. And the information that we were able to collect was about 7.64% of the CPU that was being used by this process. Now you can see that it says symbols are disabled. So if you want to see the functions that were being called when the CPU was running high on this process and you wanted to further investigate, we would go ahead and go to Trace, Configure Symbol Path, and we would verify that our symbols were set up properly. And sure enough, already had my symbol set to the Microsoft Symbol Server, and also was looking for the symbols that were being cached locally here. All right, so once we start loading the symbols, you'll see that there's an indicator that the symbols are being loaded. But the good thing is that you don't have to wait for the symbols to finish loading. If you're interested in that particular process, you could go ahead and go to the stack, and it's sorted by CPU right now. You'll see that little downwards arrow. So if you want to go ahead and expand that information, you could do that. And you can see that for the Microsoft functions, it shows up. But this is a third-party product, so it will tell you that the PDB is not found. So you have a few choices. If it's an in-house application, you want to go ahead and point your symbols to the in-house symbolic files. If it's a third-party one, what you want to go ahead and do is provide this trace to that third-party vendor so that they could investigate for you on what's happening. So luckily, on this sample application, we have the symbols for it. So we're going to go to Trace, Configure Symbol Path, and we're going to click on the plus over here. And we're going to go ahead and point it to the symbolic file for the Vernon Test, which is right here. So you can see the PDB. I'm just going to copy the path and not the actual PDB file. And I'm going to go ahead and paste it. I'm going to go ahead and click OK. And the symbols are going to go ahead and reload. So for the third-party applications, you can see that it says PDB is not found. If you had an in-house app and you wanted to point to the symbol file, we could go ahead and do that by going to Trace, Configure Symbol Path, click on the plus sign, and then pointing to the folder where the PDB file, so the symbolic file, is sitting. So in this example, it's in the administrator profile, desktop, x64 Vernon Test folder. I'm going to go ahead and copy that and paste it. And I'm going to go ahead and click OK. Once I click OK, it's going to refresh, and the UI will take a little bit of time for it to point it to the symbols for that third-party or in-house application. Once that is done, we should be able to see the actual function that is being called inside of that process that is doing the work. The work could be using the CPU, querying WMI queries. If you go ahead and point it to your symbol file, we could do that by clicking on the plus sign and adding the path to the application PDB file, which is the symbolic file. Again, you don't want to give the whole path, including the PDB name. You just want the path where the folder is. So in this case, is in my profile, desktop, x64 Vernon Test, and we went ahead and we want to go ahead and copy that to this location, and we're going to click OK. And now we could go ahead and take a look at the actual functions that was being called. Again, keep an eye here on the right side where's the percent utilized, and you can see that the first function for that process is called thread start ex. So we're going to expand this, and that's another call to call thread start ex. And the function that was causing the CPU problem, it just is called CPU hot thread in this case. You can see how simple it could be for an administrator to go ahead and get down to the thread that's causing the problem. And this type of granularity in the past, you have to take a user mode dump, open it up with WinDBG, point it to the symbols, and know the commands to get to the bottom of this.
Right. Yeah, so that's really cool. Let me ask you a question. How do you know that that's the thread that's causing the high CPU usage? I see that it's weighted at 7.61.
Right, so you can see that this is the last thread in this particular process.
Yeah.
Now, the big thing, the difference between a regular Windows debugger output and this output is that this uses from top to bottom. So the first, on an applications thread, you'll see that you'll see the RTL, which is runtime library, user thread start. So it's go from top to bottom. All the other products that we have go from bottom up.
Yeah, when you're looking at a stack, it's always from the bottom up in a debugger.
Yes, absolutely. So,
okay, so it's going to be. So are you saying that it's always the last thread in?
No, it could be something in between. So you'll see a big jump between different threads. Now, here's the thing. We're not even specifying a thread right now. We could do that. We could right-click here and select thread ID. And you can see the thread ID is to the right. We can move it to the left like this by just drag and dropping.
Yeah.
And you can see the thread number is 11992. I could expand it, and this is where most of my CPU is being utilized. Now, if this was a multi-threaded application, right, such as SQL Server or iNetInfo, you would have multiple threads, and each of those could be doing some time slicing. So let's go ahead and take a look at the Skype process as an example. We can see that there are multiple processes, multiple threads that are using up the CPU on the machine, and each of these threads have a unique set of stacks that if we keep on going down, we're able to see that we start running into processes or DLLs that are related to that specific application. And the other thing that you'll notice is that the code path may split, right? So this code path, where it was using 1.58% of CPU utilization, ends up getting split into these multiple code path right here that make up to be 1.58. So one of them is 1.10%, and then the other one is 0.48% of CPU utilization. And the code path, differs here, and then you'll see even further code path splits, and you're just trying to take a look. You always start out with the ones that are the heavier ones. You're going to go after that and see if it's something that the developer could optimize it for you guys, right? So, but it could become a little bit more complicated depending on how complex that the code is for that particular application, and how many threads are getting on the CPU and working and getting off.
Okay. So when I look at weight, you've got two weight columns that I see. There's weight in viewer, and then percent weight.
Right. So this the weight is based on the samples that we collected. You can see here this is the count. So during this almost 56 seconds, we collected 10,000 samples just on this one thread. And if I wanted to look at the individual weights, I could move this to the right of the thread ID, expand this, and each single weight will be shown. Excuse me, I would have to move it to the left right here. Each sample data would be shown based on the samples that were taken. Pause. Wait, I need to go back on this because this is where.
So Yong, here's what I'm getting at.
Mm-hmm.
If I look at the weight, the threads that you're pointing out aren't the threads that I see that have like the highest weight, and I think that might be confusing to people that are looking at this. Can you dive into that a little bit? Can you explain that a little bit?
So the question was the wait. So can you repeat that question?
Yeah, so if
Lex?
I want to
Uh-huh.
find so I think people that are watching this might get a little bit confused because
Uh-huh.
the weight doesn't you were pointing out a thread and said that this thread is the thread, but when you looked at the weight, the weight was exactly even across all threads for that process. So I guess I'm trying to correlate weight with
Mm-hmm.
that thread being the thread that's bogging us down.
Right. So the this is the amount of well, it's not only that one thread, right? It could be you can see that if I select each of these threads, the graph will highlight the time when that thread was doing the work. So
Ah,
not
okay. So and
only
that changes. Hang on. So that changes as I click on the thread.
absolutely. So you can see the graph changes on when that particular thread was doing work. So that's why it's important on any time that you're troubleshooting a performance issue, that it's critical for you to go ahead and write down the exact time of when things are occurring, especially if the problem only occurs for 5 seconds, as an example, right?
Yeah.
Because you want to be very, you know, specific to the time period of when the issue is occurring. Because if I go ahead and I'm able to select a very specific duration, I could go in there and zoom in, and you'll see that the number of threads reduce greatly, and then I'm able to go ahead and take a look, and you can see that the percent of CPU utilization was modified, right? It goes a little bit higher for the specific thread. If I go
Yeah.
ahead and unzoom and then go
Yeah.
to a different time period, the
Yep.
thread,
I think that was the missing link for me.
okay. So, yeah, so anytime that you're troubleshooting any kind of not only performance issue, but if you were troubleshooting a process that was where you double clicked on it and it was taking, 10 seconds to appear, you want to write down the exact minute and seconds of when you double clicked on it, so that we're able to be very precise on the timeline where we need to investigate. Again, because there are so many counts that are being collected during this period of time, we want to be very specific when analyzing with this tool set.
Yeah, so that makes sense. That makes and I assume that it works the same way with like disk usage and memory usage, etc.
Right. It works exactly the same. Just let me go ahead and just demonstrate to you guys disk usage as an example on this particular machine. We have disk 0. If you had a server, you could have multiple LUNs on there. I could expand it, and then by default, it will show up in this column format. But you could go ahead and choose the different columns by clicking on this drop down, and you could even create your own set of columns that you prefer, such as you want to know the process. You want to be targeting this exact process, and you want to see if it's a read or write, so you may want to move the I/O type to the left, and you'll be able to see the write, flush, and read. And then if I right click here, and I could add the path name as a regular path or as in a path tree, so
Oh, that's
that you
cool. Add path name.
all right, so I'm adding path name here, and you can see the things that we're writing about this particular process and Skype, and you can see the exact files that are being touched. So it's a write, and these are the locations that this process is using. And if you wanted to correlate with the amount of CPU that disk I/O is using, you can always add thread ID, right, like this, and I could move thread ID to the left. And for this particular write, this is the thread that is doing the work, 7304. So if I wanted to look at the stack of that, 7304, it's right here. And I would be able to see that it's related to this ETW logging. And it just happens that we're going down to the kernel, we're going down to the filter manager, NTFS, and look at this, we're doing it right? So we're able to be very precise on the code that is doing this work right here on the disk. So when we're troubleshooting any type of SQL disk I/O performance, this is the way to go, because not only do you get the pathing information, but you can see where what code is being what the code path is to get there, and you could always compare it.
That's cool. Can I go up to the graph and highlight a range? Like, see right in the middle, there's that spike of disk activity.
Right here, yeah.
No, go over. Not there. Go over to the middle.
Towards the middle, right here.
Nope. Keep going.
Right. Oh, right here.
Yeah, right there.
Okay. So this, anytime you see trace rundown, this is where you see this gray area is when I clicked on to start stopping the trace. So there's a good chance this is the trace data set. So let's go ahead and take a look. In this case, I assumed wrong. It was this program data ICU.log that is using up the most amount of disk activity, and it's doing roughly 287 megs. So this is in bytes, kilobytes, megabytes, and you can see the I/O time, which is in microseconds, so millisecond. So it took about 10 seconds to go ahead and read this much data, 287 megs worth of data on a 10-second interval. So you can see that it's the antivirus was reading this particular log file, and for 10 seconds it read about 287 megs worth of data. So that's must be how big that file is. And if I wanted to look at the stack on that, I could always go to the Microsoft antivirus engine and look at thread 1692, which is right here, and we can see that it's doing some real time protection, file system watcher, and it's scanning the file. You see this where it says scan file, and obviously we don't have the rest of the symbols for the antivirus scanner for security purposes, so the PDBs are not out there. So does that help?
Yeah, that's awesome. This is cool.
Yeah, so it's a very powerful tool set, and obviously just like any powerful tool set, there is a little bit of time that you need to invest to be able to navigate the tool set really well. But if you have a lot of servers out there that experience intermittent issues such as high CPU, high disk latency, or it's a web server that's serving and things are not running well, not only do you want tools like perfmon, ops manager running on those boxes, but you may want to go ahead and collect a sample using the Windows Performance Toolkit to collect the data while the issue is occurring, because the great thing about this is, again, the data is saved. You could port that over, and not only can you look at it, let's say that you run into a roadblock and it's beyond your Windows internals knowledge. you could go ahead and open that case up and have the support escalation engineers analyze the data set. Or if it's a third-party vendor, have that third-party vendor's support team go ahead and analyze it. All you have to do is zip this up and send it their way.
Yeah, that's really cool. And you keep saying server, but this will run on a desktop as well.
Absolutely. So the tool set runs on Windows clients and Windows Server. And the great thing about this tool set is the console version of it, starting in Windows 10 and Windows Server 2016, are included. So if you go to System32 and do a search for wpr.exe, it's in there by default. You don't have to install anything. So you could go ahead and collect data on those machines. You know, once you guys go to Windows 10 and Windows Server 2016, this is an additional tool that is shipping in box just because of the amount of help that this tool has provided for the support folks and for my organization, which is the Premier Field Engineer, when we go in and help customers with outages or, you know, optimizations of their systems.
Wow, that's really cool. So it's built in, is what you're saying.
Yeah, it's starting with Windows 10 and Windows Server 2016 Technical Preview 4 has wpr.exe in there. So you don't have to install anything. You could just do start CPU and you're good to go. You're tracing at this point, right? You reproduce your issue for roughly 10 seconds or 20 seconds, right? Once you have your issue reproduced, what you want to go ahead and do is stop this trace, and you could call it anything you want. .etl, and voila, you got the trace. It takes a little bit of time for the traces to merge, but you know, the trace is there for you to get off of a system and start analyzing. So that's a great thing that our product group went ahead and did for our new operating system. So this is another plus for administrators to look forward to Windows 10 and Windows Server 2016 going down the road.
That's pretty cool. I just need to point out that the recorder's built in, not the viewer, right?
Right. So, you know, a lot of times if you're an administrator, you just want to go ahead and copy the file off of the system, right? So, yeah, just the record is built in. If you still want to analyze it, you would have to download the Toolkit on your box and either install it. And the other thing is, let's say that you don't want to install anything because you're, installing things requires change control in a lot of companies. So instead of installing it, if you install it on your tools machine, one of the things you could do is just copy the folder off to the given box, and you're good to go. The only caveat there is on Windows 7 and 2.8 R2, there is one command that you need to go ahead and enable, which is this thing called Disable Paging Executive. So you would have to go ahead and run wpr.exe Disable Paging Executive on, like this, and you would need to reboot. So one of the things that we highly recommend for customers is this is just a registry key that is located in this location. It's something that they may want to go ahead and deploy it via group policy or via SCCM, so that when a system running Windows 7 or 2.8 R2, you could go ahead and collect the data set and not worry about not being able to see the stack information. So, so it's under Session Manager, Memory Management, and it's called Disable Page Executive. It sets the value to 1, and you have to go ahead and reboot. Now, one of the things that a lot of customers, when I mention about this particular registry setting, is that they'll go, does that disable the page file? No, this only disables the executive inside of the kernel from paging it out to the page file. So what's the hit on the system? 7 megs of additional non-page pool memory. Now, 64-bit, 7 megs usually is nothing, and on even on 32-bit, 7 megs, most systems will be able to go with less.
Yeah, it's not a big deal. We have on 32-bit, we have what, 4 gigs of address space, and
right, and then it's 2 gigs. 2 gigs of that is for the kernel on in Windows 7 and Windows Server 2008 R2. Now, the good thing is on Windows 8 and 2012, the amount of the kernel memory, the page pool, non-page pool memory have been increased anyhow. So it shouldn't be an issue for most of the organizations out there, unless they're really, really running low on physical memory on the system. But then that's a different issue that they're running into, right? So, but so a lot of the Fortune 500 companies that we have visited have deployed these to their Windows 7 and 2008 R2. Again, Windows 8 2012, Windows 8.1, 2012 R2, Windows 10, and 2016 don't require to have this pushed out to them, because we're able to collect the data without this being turned on. The only caveat there is if there are third-party kernel information, kernel drivers, on those newer OSs, you may still need to enable that if you get down to that level. But again, by default on those newer operating systems, you don't have to do this to be able to see the functions that are being called.
Okay, that sounds pretty cool.
And so, yeah, it's a really nice tool. I think that a lot of IT administrators, once they start taking advantage of this and leveraging it, they're going to see some really interesting things to optimize their environment, to make their systems run leaner, run with more load, and also be able to service the end users quicker, which at the end of the day, for the business, from a business perspective, that is, that's big ROI, right? Return on investment for a free tool, because it will let you have your workers to be a lot more productive. And also, you may be able to go ahead and save resources on the system, so that you could, maybe delay on purchasing new hardware, because it was something from a software level. So instead of purchasing, 80 terminal servers out there, you really just needed 70 as an example, because you were able to tweak the applications and services enough where they were running optimally. So that's things that IT administrators should look forward to.
Yep. Yeah, I've already got some customers in mind that I think will benefit from this.
Absolutely. So, if they're interested on learning more about it, our Vital Signs Advanced Workshop goes through hands-on labs on this, and obviously has a lot of instructions on gotchas, best practices, and the other thing that they'll end up getting by having this workshop is that everybody that is accredited has been working on this tool set for the last 2 or 3 years. So that means that they bring a wealth of knowledge, and it's a great thing for IT administrators to ramp up quickly into the tool set.
Young man, that was cool. Thank you for doing it.
Thanks, Lex. Thank you for inviting me, and hope you guys were able to see a glimpse of what the Windows Performance Toolkit is able to provide you and help you guys down the road in your Windows and Windows Server environment. Thanks.
Awesome. And guys, that's just about it for this show. So another show bites the dust.
All right. Thank you.